Google Earth Engine is a free cloud-based platform for geospatial analysis. It lets us process satellite imagery, detect the landscape patterns, and generate maps instantly without heavy software or GPUs. Today, I'll show how landscape architects can use Earth Engine for quick environmental insights like vegetation, water, shade, slope, and land use detection, all using simple code. To begin, go to the Earth Engine homepage. The link is at the top of this page. This is where Google introduces the platform, its datasets, and sample tutorials. Click Get Started and sign in with your Google account. Once your access is approved, you'll have full use of Earth Engine's tools. After signing in, click Code Editor. This brings you to the main workspace. On the left is the script panel, in the center is the map, and on the right is the console and inspector. This is where we'll run analysis. First, we'll use Earth Engine to detect vegetation. NDVI stands for Normalized Difference Vegetation Index. It highlights healthy plants using red and near-infrared wavelengths. To generate the script, I'll go to ChatGPT, enter a short prompt asking for NDVI code, then copy and paste the result into Earth Engine. After running the code, Earth Engine displays a color-coded vegetation map. Darker greens show stronger plant health. This gives a quick view of tree cover, parks, and green corridors. Next, we'll detect water bodies. This uses something called the NDWI index, which highlights moisture by comparing green and infrared bands. Again, I asked ChatGPT for a land water classification script to paste it into the editor and run it. The output appears instantly. Areas like reservoirs, rivers, and coastliners show up clearly. This helps in flood studies, drainage planning, and environmental evaluation. Now we'll look at shade or solar exposure. This uses pixel brightness and vegetation to identify cool, shaded zones and sun-exposed areas. I generate the codes with ChatGPT, paste it in, and run it. The result shows areas of likely shade, tree canopy shadows, building shadows, and darker surfaces. This is helpful for outdoor comfort studies and microclimate design. Next is slope analysis. Earth Engine can compute slope from global elevation datasets. This helps us understand terrain form, runoff direction, and site constraints. I asked ChatGPT for a slope map script, paste it into the editor, and execute it. Steeper slopes appear in brighter colors, while flat areas appear darker. This systematic terrain map supports grading, accessibility planning, and erosion risk studies. Earth Engine also supports simple land use identification using spectral signatures. With AI-generated code, we can classify built-up zones, housing estates, industrial areas, and parks. I get the script from ChatGPT, paste it, and run it. The output shows color-coded land use classes. This helps with site context analysis, urban planning, and understanding neighborhood structure. Finally, after generating any map, we can export the result. We simply use the Export Image to Drive function, choose resolution and file format, and Earth Engine generates a downloadable map. This allows us to include these layers in reports, diagrams, or presentations. Thank you.